right, so now we're down to Matt File from DataStax.
First of all, thanks for coming, and I know we're getting towards the end, so I'll try to keep this short enough. But DataStax is the commercial company behind Cassandra. And Cassandra is a very high-performance, scalable database that was built for big data. And if you look at its where it came from, it'll be very evident. It was based off of the Google Bigtable data model combined with the Amazon Dynamo architecture. And that was merged at Facebook, which is where it was open sourced. So it has big data in its history just based on those companies alone. And if you start to wonder, why are those companies important? It's because big data is no longer just a Fortune 500 problem. We're seeing a combination of commodity hardware dropping in price, making it economically feasible for anyone to use big data. And what that means for everyone in here, assuming you're not at a Fortune 500, is that if you're not using big data for your advantage, your competitor is. And so you need a system that can keep up with you. One of the quotes that was floating around the office a few months ago was that scalability is sort of like rocket science, and there are not enough rocket scientists on the planet to satisfy every business out there. And we firmly believe that. And so what all of these products are offering is the ability to handle the scalability for you. Whenever we looked at the original architecture of this, we thought that if you're going to tackle a really hard problem, you better start really simple. And so every node in our cluster is the exact same. There is no name node, there is no master node, there is no single point of failure. And that's really good because if you're running things in commodity hardware, you should expect failure to happen very frequently. And the last thing you want to have happen is that failure to result in some sort of downtime. So just looking at the architecture before we move on, every node on that is the same. You can replicate copies of your data between nodes, as many as you desire, for your specific use cases. Just a few high-level points about the technology itself. It's a multi-master, rather it's actually a completely peer-to-peer masterless architecture. Because it's got that Dynamo architecture at its core, you can do multiple data centers better than anything else out there that I know of. And when I say multiple data centers, I don't mean 2, I mean N. So you can literally pick as many different data centers as you desire and do reads and writes at any of those. Why does that matter? Well, a couple reasons. First, all of us can do that now thanks to Amazon. Amazon commoditized data centers to the point through availability regions that if my mom could program, she could launch machines in 5 different data centers around the world for $2 an hour. It's that simple. So it's available. Following up on that is there's nothing worse than having a large amount of data than having to either running in the scenario where you run out of space in a single data center, and it does happen, or transporting that data to your end user. And in today's world where users are spread out across the world, you don't want to have any issue with latency getting that data to them. It's a linearly scalable system, so again, you simply add more machines as you need more capacity, whether that's for storage itself or read and write requests. It's also built for larger than memory data sets, and I'm going to combine that bullet point with the next to last one around caching, where if you think about what caching is, it is a ratio of memory to overall storage. And the stuff that's in memory is really, really fast and is great for fast reads, but a lot of times it's economically infeasible to store all of your data in memory at all times. So in this scenario, we've integrated the caching layer with the persistent data store level so that the data set that you desire is available at a very fast manner, and you can simply add more machines to the cluster to keep the ratio of memory to disk what you want it to be at all times. The result is it makes life better for your developer and operator. The ops guys don't have to worry about 2 classes of servers, and the developers don't have to worry about interacting with 2 types of systems or things like a cache that's out of sync with your persistent data layer. It's got extremely fast performance per node, and again, that's linearly scalable, and we'll see in the next slide just some numbers around what that looks like. But one of the important things to ask is, reads are sort of easy, but writes are sort of hard. And the reason for that is durability matters, especially in the enterprise. A power flicker or a server crashing at an inopportune time cannot result in data corruption, and an emphasis has been put on from the very beginning with Cassandra that data simply can never be lost. The result is any server can fail at any time, data is not lost, every write is committed to disk before it's acknowledged to the client, and then on top of that you can specify how many copies you want in how many data centers. The speed of the writes is also another important point. It's really hard to do fast writes while also guaranteeing durability. So we never do in-place writes. It's append only. I'm sorry, it's actually a combination of append only commit log with a write once architecture for the main storage of the actual data directories. And then last but not least, there's this notion of consistency, which I'm actually a little surprised hadn't come up already, but you hear about strong consistency, you hear about eventual consistency. Cassandra is tunably consistent, and the reason for that is you actually want both. Strongly consistent is great for multiple copies in your local data center. Before you acknowledge your client, you want to make sure that you've got multiple copies because, again, I think it was mentioned earlier, commodity hardware fails very frequently. And the more you add, the more you should expect failure. However, you don't want to give up performance when you're replicating across a WAN. You don't want to have to block for the speed of light to get from the United States to Asia to acknowledge your client because you're talking about potentially hundreds of milliseconds. So the combination of strong consistency at your local data center combined with the option for eventual consistency across the WAN is a really strong point. And again, going back to the beginning, Amazon commoditized data centers for all of us. So we can all take the power and advantage that offers. Going on to just a quick numbers game. These are numbers for both reads and writes between two versions of Cassandra. .8's the latest. These numbers are per node, which means that as you add more machines to your cluster, these numbers will scale linearly. So for a single machine, today you see roughly about a little over 20,000 reads. You see a little over 20,000 reads per second. And a little over 30,000 writes per second on one machine. 2 machines is double that, 3 machines is triple that. And today in production, we've got customers with over 1,000 nodes. Examples are guys like right here, Constant Contact is using us. Netflix has recently announced they're moving their entire data infrastructure over to Cassandra. So every time you log in or play or pause a movie for their 22 million users, that's hitting them. And it's all done on commodity hardware where failure is expected. So the performance numbers speak for themselves, and I'll take any questions that I can answer.
Did you break it out by solid-state drive versus disk drive?
I need to look up the stats. I think this was done on Amazon, but I need to verify that. Solid-state drives, I can get those numbers for you.
Anybody else?
So we, our main relational databases we run on Fusion.io, and those, the transaction systems, the data's not that big there, and so we'll run a RAID 10 pair of 2 Fusion.io drives. It's somewhat miraculous what that does if it works for your database. We tried actually to run the data warehouse, our data warehouse on a Fusion.io cluster. It didn't actually work out that well. There's some incompatibilities. It was pretty early. And so we ended up running our data warehouse on, we use Aster, but we run that on EC2, which I think is a little bit, may seem kind of backwards, but the stuff we run on EC2 in the cloud is actually the BI traditional data warehouses. And that works really, really well because I think, as Dwight mentioned, scales horizontally. We use EC2 for the storage there, and it's worked quite well.
Yeah, we use local storage. So we use Block for relational. We use a company called 3Power off of SAN for our relational database, block storage, and local storage. So we put commodity servers out. We actually trust the multiple writes. So it's RAID 0 across 3 disks for the data store and the commit logs on a single disk. We write it to 3 different places in one data center and 3 in another. And by the way, we do backups. So we, even with multiple data centers and all this distributed system stuff, we still back it up and eventually get it to tape still, believe it or not.
Really?
Yeah.
That's impressive.
We use data domain for data deduplication and things like that, but in the end we put it to tape on a real conservative archiving schedule, not nightly fulls and things like that. But
Is that part of your business practices and requirements on that end, or?
yeah, so it's business continuity, DR, best practice,
I think all of these products were kind of designed to run on commodity hardware and commodity networks.
Yeah.
Right, so they're very cloud friendly in that sense because that's usually what you're dealing with in
Yeah.
that environment. So they work very well with direct attached storage because you do they all do have lots of replication capabilities. They'll work great on SAN, but you don't have to have a SAN. So.
Yeah.